Welcome to Precalculus Concept 29D. Underneath angles. Welcome to Precalculus Concept 29D. Underneath inverse trig functions. There are 4 boxes here, and let's begin. So I wonder if you remember this from a previous chapter in this book that we did together. If I want f of f inverse of x, I wonder if you can tell me, or if you remember, what the value is going to be of this. And likewise, I wonder if you can remember, if you can tell me, what is f inverse of f of x? If these are inverse functions of each other, what must go in those boxes? The answer is x. Hopefully you remember that. Remember, so to show that 2 functions were inverses of each other, you had to use function composition and show that f of f inverse of x was x, and then likewise f inverse of f of x was x. The same principle applies to what we're going to be doing in this video lesson. Box number 2 are the basic properties for inverse functions. So the way that the thing that helps me the most is understanding the picture for each one. So in red over here, I have for you the inverse sine and the inverse tangent. You have to remember that both inverse sine and inverse tangent live between quadrants number 1 and quadrants number 2, and have to stay in bounds between negative pi over 2 and positive pi over 2. For cosine, you have to remember that the inverse cosine lives between quadrants number 1 and quadrants number 2. Oh, did I say 2 over here? I meant 4. Sorry, guys. Quadrants 1 and quadrant 4. For inverse cosine, it's quadrant 1 and quadrant 2. And remember, this is all because of that domain restriction that I showed you in the other videos about how the graphs need to have a domain restriction in order to be inverse functions. So anyways, for inverse cosine, it lives between 0 and pi radians. Inverse cosine is positive in quadrant 1, negative in quadrant 2. Both inverse sine and tangent have the same picture between quadrants 1 and quadrants 4. Okay, positive in quadrant 1, negative in quadrant 4, and you have to stay within bounds of positive pi over 2 to negative pi over 2. So that's what always helps me. But another thing that helps students to understand this stuff is understanding this in terms of functions. So for the inverse sine, okay, the only things that we are allowed to plug into inverse sine have to be between negative 1 and 1. Same thing goes for the inverse cosine. The only things that we are allowed to plug in to an inverse cosine have to be between negative 1 and 1. Okay? The things that come out of this are going to be angles that are stuck between, for the inverse sine, negative pi over 2 and positive pi over 2. Okay? But for cosine, it's going to be between 0 and pi. Okay? For tangent, you can plug whatever you want into the tangent function, any real angle that you want, but you're going to be bounded by the same bound for the sine on the output, which is negative pi over 2 to positive pi over 2. So this is just helpful in thinking about it when we go to actually solve some of these. Okay, here's box 3. Let's find the exact value, if it's even possible. So part A says the cosine of the inverse cosine of 0.6 radians. Okay, so get your calculators out and make sure that you are in radian mode, and just go ahead and plug it in and play with it. So how about the cosine of the inverse cosine of 0.6? Push enter. No one should really be surprised that the answer is 0.6. Because look, if I plugged anything into this value that's within bounds, okay? If I plugged in like 0.25, well then I'm going to get out 0.25. So this goes back to box 1, just saying that the cosine of the inverse cosine of an angle is just itself as long as that angle is within bounds, okay? So in all of these problems, I suggest that we have to work from the inside out. So we evaluate this and then we evaluate that, but in this particular case, we can just go ahead and use the property and get 0.6. That's not really a big wheel. Okay, let's take a look at example B here. Again, we're going to work from the inside out. So this says the inverse sine of the sine of 3 pi over 2. I'll say that again. This says the inverse sine of the sine of 3 pi over 2. So working from the inside out, let's think about my unit circle. Here is 3 pi over 2. It's all the way around over here, okay? And that is associated with a coordinate point, which we call 0, negative 1. and I want the sine of that value, so this is x and y, so then I'm going to look at this value and realize that's -1. So now my problem says I'm looking for the inverse sine of a value of -1. Well, I am allowed to plug in a -1 to that, so I want the angle whose sine is worth -1. So I can go ahead and use my calculator and say the inverse sine of -1 and use my calculator, make sure I'm in radian mode, and I'm getting -1.57 for an output value. Okay, that shouldn't be a surprise to anybody. The other way that we could have done this is by saying the inverse sine of the sine of 3 pi and then divided by 2. 2. And then close that. And notice to get the exact same answer rounded to 2 decimal places of -1.57. Okay, so that shouldn't be a big deal. -1.57 is, if you think about that, that is second pi divided by 2. Hopefully you guys recognize that. So why is this the case? Because this is saying, if I draw this back in bounds over here, right, what angle, this says what angle has a sine value that's worth -1 in between negative pi over 2 and positive pi over 2, and that value would be negative pi over 2. So the answer is -1.57 or negative pi over 2. Okay, let's do example C here. Again, we want to work from the inside out. This says the cosine of the inverse cosine of 1.5. Well, hopefully bells and whistles are going off in your head, because you should realize that you are not allowed to plug a number that's outside of -1 and 1 into an inverse cosine. So this answer is going to be completely, we're going to get domain error, undefined. So watch here. If I do cosine of the inverse cosine of 1.5, close parentheses, the calculator is going to give me a domain error because the 1.5 is outside of the bounds between -1 and +1. So sometimes you have to be just helpful to know what you're allowed to take the inverse cosine of. Okay, let's do more examples. Box 4, this is the last two that we're going to do. This says the cosine of the inverse tangent of 5/12. Okay, so we're going to start from the inside out. I'm dealing with an inverse tangent, so therefore I know that I have to be somewhere either in quadrant 1 or somewhere in quadrant number 4. And since my output value is positive, I can be over there in quadrant number 1. So what you do is you draw a triangle in quadrant 1 and you label the sides accordingly. So the tangent is the ratio of the opposite to the adjacent. So this value has to be 5. This value has to be 12. And then from there, you can figure out what this radius has to be. So I'll call this r. So r, of course, is going to be the square root of 12 squared plus 5 squared. So r is going to be the square root of 144 plus 25. So r equals the square root of 169. So r is equal to 13, since this is all squared for Pythagorean theorem stuff. So now my radius is worth 13. Okay. Once I've drawn the picture, and I have my angle, because after all, this means the angle whose tangent is worth a value of 5 to 12. Then I have my radius of 13, and what do I want? I want the cosine of that angle. So the cosine is the value of the adjacent to the hypotenuse. So this whole thing has an exact value of 12 over 13. Okay? So drawing the picture is the right way to go to do these problems. Okay, part B, this is the last one that we're going to do. Find the exact value for the cotangent of the inverse sine of -1/3. So again, we are going to work from the inside out. I am noticing that I'm dealing with an inverse sine, so therefore I must be either in quadrant number 1 or in quadrant number 4. I'm noticing that the value is negative, so I must be somewhere in quadrant number 4. So this is the picture I'm working with. And I know that this triangle has an opposite side that's worth -1 and a hypotenuse that's worth 3. So therefore, I'm left to figure out what this is. And when I do the math, it ends up being 2 radical 2. That's just a regular old Pythagorean theorem stuff. And I want the cotangent of this angle. So the cotangent is 1 over the tangent. And I remember that the tangent is worth -1 divided by Okay, the tangent is worth negative 1 divided by 2 radical 2. So therefore, the cotangent is going to be 1 over that. So that's just going to be negative 2 radical 2. So this whole thing has a value that is worth negative 2 radical 2.